Okay, we've received the phone call. Client wants a rewire of a 3-bedroom house. So have a chat over the phone. She wants a full rewire, new consumer unit, all the old cabling removed. Go through timings, does it fit in with your diary? And also find out if it's occupied or unoccupied. This is very important. Unoccupied, that's great, you can just crack on, no worries. If it's occupied, that's very challenging. People living there, tidy up every night, get the power back on every night. Oh, I'd think long and hard about doing an occupied rewire. Okay, you've had a walk around the property with the client, you've got a good understanding of what she wants, and now you've got to put your quote together. An awful lot of things to think about. We're not going to go through these all now, we'll go through them bit by bit throughout these series of videos. Right, we're keen to start work. So the first thing we do is have a look in the fuse board cupboard, where we'll find the fuse board, the meter and the service cutout. There's no point testing anything after the consumer unit. That's all getting ripped out. We're getting a new board, all new cables. No point testing any of that. But we can test if you've got an earth coming into the property, the supply characteristics and earthing. We can check these. We can check if we've got the prospective fault current. We can check the ZE, because these are the things that are beyond our control. If we've got a bad ZE reading, we're going to have to call the DNO to come and look at that. And also, there's no means of isolation for this fuse board. We need to take this fuse board away, and there's no way we can isolate this to do it safely without pulling the main fuse. And technically, we're not allowed to pull the main fuse, but you can get the supply company to come and fit an isolator. So these are jobs that are good to start on straight away, and if there is issue, we can get the various companies round to help us out. The ZE test is a measurement of the impedance of your earth fault loop path, and that path is the incoming line supply and the returning earth path to the transformer in the street. It's the external element. We measured this at the consumer unit generally between the incoming live conductor, the main switch, and the earthing conductor. But it's important that we don't have any parallel paths on this earthing conductor. And this is all in the characteristics of supply. They need to know what the ZE is. When you're doing your ZE test, it's important that you don't have any parallel paths. Normally you do your ZE test at the consumer unit between the line, the main switch, and the earthing conductor, the disconnected earthing conductor. You disconnect the earthing conductor from the earthing terminal and the fuse board. But is this earthing conductor being disconnected? If we follow down, it hasn't, because there's an external earthing terminal with the main protective bonding conductors on. So if we test from here, we're getting the parallel paths of the gas and water pipes as well, and we're not getting the ZE reading of the earthing conductor and the line conductor. We've got additional connections, so we need to be careful there that we don't do that. So what we can do is we can either disconnect these bonding conductors, and then we could test from here. If you've got just the same one connection going all the way through, that's okay, we could do that. We'll get a reading. Even better, disconnect the earthing conductor here, then you know that there's no possibility of having any parallel paths, because you're connecting directly to the incoming source of the earth, the means of earthing. So you put your clamp on there and you probe on here on the main switch, incoming line, and then you do your test. You know you're not getting any parallel paths. The reason why parallel paths can be a problem is because they give us a false earth. If there was a break in this metal cable sheath, we might not actually have an earth path, so the installation wouldn't be earthed. But we get the impression that we have an earth path because we're reading the earth through the gas and water pipes. And the potential further down the line that the gas and water might be swapped out for plastic services, pipe work, then you wouldn't have any earth at all. You're not supposed to use gas or water pipes for earthing anyway. You have to use an earthing conductor, either a TT, a TNS or a TNCS earthing conductor to earth the property. So yeah, it's important that when you do this test, you are connecting to the earthing conductor and you haven't got any parallel paths. Okay, so we've opened the fuse board up. We want to do our ZE test. We've followed all the safe isolation procedure, we won't go through that. And we test between the line and the earth. Now this is the conductor that goes to the main earthing terminal. And as I mentioned in the previous section, that we're going to get parallel paths here, because we measure here between the line and the earth. If you follow this path round, goes to the earthing terminal here. We've got these other conductors coming off it, which possibly go to our bonding, our gas and water. Sometimes you see connections and no services, you're not quite sure what they're actually for, if they're actually connected to anything. Doesn't matter, it's all getting ripped out. What we want to confirm is the earthing conductor here, our ZE. So we can't test it from here because we've got these connections. So we need to disconnect this and just get to the earthing conductor here. Okay, in our setup, we've got an old-fashioned type main earthing terminal. It's like a nut and bolt, where all the various conductors are brought in, twisted around each other and tightened with a nut. We can't individually remove the conductors like you can with the earth bars. You can just undo that screw, pull that conductor out. So we need to remove this and replace it with one of these. But you've got to take good care here. This is quite a stiff wire that comes, it's soldered onto the supply cable. And if you've got quite a nice long length of that, and you can remove that safely without putting any pressure or strain on the soldered joint, I'm quite happy to do that. But if you've got any doubt, if it looks like this looks old and dodgy, don't bother. Call the DNO and tell them to come in and reconnect your earth. But if you're not going to put any pressure or strain on the connection, I'm quite happy to undo this and re-terminate it in an earth bar like this, and then we can easily take our ZE reading because it's all disconnected. If we've got this kind of setup, sometimes there's a clamp on the supply cable. You get various different types of clamps. The DNO might have done this, but often you see a DIY type job where somebody's used a BS951 bonding clamp on the supply cable. You shouldn't do that because the bonding clamp is designed to clamp around a copper pipe, and it does it by compression. It pulls tight onto it. You don't want to be pulling tight onto a electrical supply cable. This because you could crush the cable and short out the connection. The cable's inside, and that's just going to cause mayhem. So don't be tempted to work on this at all. If it's loose, don't be tempted to try and nip it up. Don't be dealing with that at all. I'm happy to deal with this section here, this end here, because we can unscrew from the main earthing terminal and we can test from there. But I never touch these connections here. If there's any issues with this here, the clamp, call the DNO to come and deal with that, because you do not want to be causing any short on this cable. That's just going to cause mayhem. Right, we've got our new main earthing terminal. I've removed the nut and bolt type, and I was only happy to do that because I knew I had a nice flexible earthing connection. The earthing conductor was nice and long and it wouldn't be putting any strain on the soldering joint, and that's got its fabric wrap as well, so that's well protected. So I was happy to swap that out. I've replaced the old bonding, what I presume is the bonding, and so with that, those earthing connections are still in place. I haven't installed the main protective bonding yet because we're not sure what's happening with the gas and plumbing, but I've replaced the conductor going to the consumer unit with a 16mm squared green and yellow conductor. The electrical safety connection, do not remove, is being installed. That has to be there so people don't start disconnecting this. And I've also labelled what each of the conductors does. So there we go, that's our nice new shiny main earthing terminal. Right, we have to record the earthing arrangements. In the UK, there's three main types. The first one is TNS. This is where we use the supply cable as the earth path, the earth return path. We have the earthing conductor connected to the metal sheath of the cable, and that goes onto the MET. We have TNCS. This is where the neutral and the earth in the supply cable are combined. This is external to the property. And when it enters the property, the neutral and the earth are separated, TNCS, combined and separated. So the neutral is used as your earth return path. We also have a TT system. This is where an earth is not supplied. We have to supply our own earth. This is generally via a rod in the ground. We bring the conductor into the house and connect it to the main earthing terminal where all our CPCs and all of the earthing connections go on to. Right, I've had a good tidy up of the earthing system. I've got rid of the old nut and bolt MET, installed an 8-way earth block. I've reconnected the old bonding conductors, and I've run a new connection from the MET to the earth bar in the fuse board, and I've got rid of the old earth connection that went back to the old nut. So I've got everything in place for when I want to connect everything back together again. The last thing I need to connect up is my main earthing terminal to the MET, but I don't want to do that until I've done my test because I don't want any parallel paths. So it's a simple enough test. Clamp on the earthing conductor, probe on the incoming live terminal of your main switch, press your button, we get a reading. In this case we've got 0.21 ohms. I'm happy with that. So that's our ZE reading. And I'm happy because it's underneath the maximum, TNS. The maximum is 0.8. You want to be getting less than that, which we have. If it's TNCS, it's 0.35. That's why it's important to know what your earthing arrangements are, TNCS, TNS, because they have different maximum readings. So we've got our reading. We record that when we use it on our certificate later on. So we're happy that we've got a good earth coming into the property. We've got our ZE reading. And so very importantly now, we need to re-terminate the earthing conductor back into the main earthing terminal. Nip that up nice and tight. Make sure all our connections are good. All the earth are back in place. And then we can re-energise the installation. So in your meter cupboard, who owns what? Well, the supply cable and the cutout, this is the responsibility of the DNO, the distribution network operators. The meter and the tails coming into it and leaving it are the responsibility of the person who you pay your bill to, your energy supplier. And the fuse board and all the circuits, final circuits of the fuse board, that's your responsibility. The DNO is also responsible. If they provide an earth, they have to maintain that, but they don't have to supply an earth. You think of a TT type system, there's no earth supplied there, but if they do provide an earth, it's their duty to maintain it. So the DNO is also responsible for the wooden board that everything's attached to, and when you're doing initial checks, just make sure it's in good condition, it's not damaged, and it's not coming away from the wall. Sometimes I see them hanging right off the wall and it's putting strain on the supply cable. Now don't you try and fix that back, don't try and push it back if it is hanging off the wall. Call the DNO, they're responsible for this board and they will come and fix it. Reason being is it's connected to the supply cable, and this supply cable could be 50, 60 or more years old, and it doesn't take kindly to being moved. And if you start pushing this board about trying to bend it back into place, you could cause a short in the cable, and that could cause real problems. So if the board is damaged in any way, get the DNO to come and look at it. It's their responsibility. Sometimes the client wants to have the consumer unit, the fuse board, in a different location. That's okay, we can do that relatively simply. We'd put a switch fuse here, run arm and cable from there to the new location, and you can mount your new consumer unit wherever you want it, really, within reason. But what we can't do, we can't move the meter and we can't move the service head. If you wanted to move the meter, you'd have to get in touch with the meter people, the supplier, and they'd have to do that. If you wanted to move the cutout, you'd have to call the DNO, and they'd come and have a look and give a quote for the job. They wouldn't actually move this at all. They wouldn't want to try and shift this cable. Like I said before, this cable is very old and it's unsafe to move. They'd probably just cut this supply off, bring a new supply in from the street. Generally what they do is put a box outside now. So you'd have your cutout in the box outside. You'd run your tails into the house for your fuse board and your meter. So yeah, we can move the fuse board, but nothing else. The DNO are responsible for the supply coming in. They're not responsible for anything after the service head, the meters, any final circuits, they're not responsible for. And that can sometimes cause issue, because sometimes you've got a service head in the upstairs flat, but it goes via the downstairs flat service head. But the DNO will only take responsibility for the one downstairs. They say the upstairs service head That's the responsibility of the building network operator. That all sounds very grand, and you can imagine that's the case in a big office or some factory or something like that. But this is just your standard two flat house, you haven't got a building network operator. Um, you just want your service is dealing with, but they won't do that. And so quite often what you have to do is actually run a whole new supply in from the street because the DNO will not work on this, and you can't work on this because you've got to isolate this section. So that can often cause problems. When we're doing our initial checks on the incoming services, we need to consider the size of the supply fuse. Generally, if it's an older property, it's going to be 60 amps. That might need upgrading to a 100 amp supply if they're going to be using things that need more current, the vehicle charging and such. So that's the job for the DNO. You're going to have to get in touch with them. You'll have to fill in a form, tell them why you want your service alterated. You can do this all online. You fill the form in and they'll come around and have a look and see what they need to do. Because the tails, if you need to increase the supply, they'll check that everything on their end is able to do that. They won't just come around and stick another fuse in, a 100 amp fuse. They'll check what's going on with their setup, see if it's suitable for a larger supply. And also the tails will need to be upgraded as well. So that would be the metering people that would need to be doing that. So yeah, if the supply fuse needs to be increased, if you need a larger rated fuse for your installation, get on with the DNO straight away and get that ball rolling as well. Because there was no way of safely isolating this fuse board so we can replace it, we have to get an isolator fitted, pictured one here. Now the meter people need to do this and they can take ages to get around to doing it, so you want to get that ball rolling straight away. So you need to tell your client to phone their supplier, people that pay the bill to, and get them to speak to the metering department and tell them to say that you need an isolator fitted as you're replacing the consumer unit. This can sometimes take ages because the supply companies, they just think they're to collect money really. They don't realise they've got a job to do, actually servicing things. So they might get passed backwards and forwards to various different teams before they eventually get to speak to somebody who knows what they're talking about, and they will send somebody round to fit this isolator. They'll come, connect it into the meter. They'll also connect it back up to the fuse board if you want them to. I haven't put the tails into the fuse board here. They've just got their tails into their end. This is the contractor's end. We're allowed to open this bit because we can isolate it safely. It's all disconnected. We can put our tails in there and then we can work safely on the new board. So yes, get them to call the meter people straight away and get them to fit an isolator. Right, the main fuse. We're not allowed to pull this, the service fuse. This is the DNO's equipment and they don't like us to interfere with their equipment. And as you can see, there's nothing between the transformer and this connection here. That goes straight out the house, down the street and into the transformer. So there's nothing between you and the transformer. And if there's a fault here, you're going to get a massive fault current. So we don't want to be interfering with this area whatsoever. And this fuse might have been in place for the last 40, 50, 60 years. Could have been there for ages. So pulling on that could get jammed, could get stuck, could break in your hand. So no. Get this meter people to come and do it. That's their job. That's what they're trained to do. So let them get on with it. You've got plenty to be getting on with. Some other things to look out for when you're looking at the condition of the incoming services. Here we've got a situation here. It's a possible fuse neutral. This is where you've got a fuse in the incoming line, live conductor, and in the neutral. This might have been swapped out years ago for a solid link, but there's a possibility there could be a fuse in there. You need to investigate that with the DNO because a fuse neutral is potentially dangerous. It's also a cast iron head. There might be a situation where there are old tails, cloth covered or VAR tails, vulcanized India rubber. These can perish and disintegrate over the years, and this is many decades old, so that might need upgrading. And also, we often find on Headley blocks the cover's missing. I see this quite often. This is in the neutral here. That needs to be sorted out as well. So basically, you're just checking that the service is all in good condition. There's no damage, nothing's broken, and everything's good for you to connect to it, because you don't want to be connecting your nice new fuse board onto some dodgy old rubbish. I've inquired the D&O quite a few times about these service heads, ones I've thought maybe have served the time. Sometimes they're quite happy for quite old heads to remain in service. They sent me this message saying cutouts will only be changed under the following circumstances: if it's damaged or faulty, if it's deteriorated through natural aging, wear and tear, if it's type with the fuse neutral, if the metal clad casing is unearthed, or the cutout is deemed to be overloaded. Quite often you see black pitch dripping out of the service head, and that's a good indication that things are too hot inside the fuse, a loose connection or whatever, and the actual pitch inside is starting to melt and drip out. So if you see that, starting to call the D&O, they'll come around and investigate. They'll be around quite quickly. But just a quick word on the fuse neutral and why that's dangerous. Here we have the service cutout with the fuse in the line and in the neutral, and for whatever reason this neutral fuse is blown, so that means you've got no return path back to the transformer, so it will appear like all the power is off in the installation because you've got no path back to the transformer. So when you go to do your testing and looking around seeing what's going on, you might be a danger of you coming in contact with the live wire, the line wire, especially if you're thinking there's no power, everything's off. And this way you've got to be super careful. And this is why you always need to carry out your safe isolation and test everything all the time. Test for dead all the time. You've got to test this line to unearth, the neutral to unearth. You always test. Because in this situation here, the line is still powered up, still energized. It's just not returning back on the neutral. But if you touch that line wire, you become that neutral. You become that return path, the earth path, back to the transformer. So you could have this load going through you. That's why a fuse neutral is very dangerous, because the potential that you actually become the return path back to the transformer. So good care needs to be taken. And as always, safe isolation and making sure that everything is dead, every conductor is dead before you start doing any investigation. As mentioned, the D&O are quite happy for metal cutouts to remain in continued service as long as they meet that set criteria. One of the points was that they'll replace the cutout if it's got a rewirable fuse in it. Now if you've got a really old cutout, it's bound to have a rewirable fuse in it, so it meets the D&O's requirements to replace it. So give them a call, send them a picture. If you're not sure, send them a picture, they'll have a look at it, tell you what they think. Okay, so the meter people can't come and fit an isolator for a couple of weeks, but that's okay. It's not going to stop us cracking on and getting some work done. What I generally do in that situation is I'll keep the old board, because obviously we can't put the new one in because the tails are going to be live, and I'll utilise one of the circuits in the old fuse board. I generally strip everything out, pull all the conductors out, all the cables out of the old fuse board, so we know that everything in the house is dead, so we don't have to worry about that anymore. Cables right out the fuse board, we know that there's no power in these cables anymore. But just double check that there's only one fuse board, because you'll have people working in the house who are not electrically skilled. They won't be testing stuff, they'll just be chopping through things and pulling things down and ripping things out. So you want to be 100% sure that there's no power left anywhere in the house apart from in this area. So just have a good walk around, make sure that everything is disconnected. There's no other fuse board which might be powering something. So then what I like to do is I'll put in this is a kind of rewirable Wirex type board with the rewirable fuses. I often just swap it out for a B20 plug-in fuse, just in case there's any issue. It's just easier to switch that back on again than rewiring one of these. And then I'll run an RCD socket off that, just a radial off it, 2.5 radial to this socket on a B20 fuse. So we've got RCD protection. So we've got a temporary supply, so anybody in can charge the batteries, plug the kettle in, whatever they need. So this is just a temporary supply. We can improve this later down the line. But I like to get the conductors out of the fuse board as soon as I can, so people can crack on with any demolition work they need to do. But don't forget, this socket needs to be tested. This is a new circuit. Even though it's a temporary supply, we've still got to do everything right. We need to do our ZS. R1 plus R2s. That's going to be tiny. Insulation resistance again, there's a tiny little bit of cable, but got to do things right. And also your RCD tripping times. Make sure you've got all this recorded. People will be using this, so we need to treat it as a proper installation, even though it's only temporary. Test it and record it, and everything will be good. We've got our temporary supply, so everybody can crack on with some work. You do have to take a view though on if the old board you're going to use for your temporary supply is suitable for continued use. Take this one for example, another rewirable board, but this is an older type with ceramic fuses. I wouldn't want to use this board really. Few reasons. There's going to be asbestos possibly behind these fuses. When you pull them out, there's little asbestos flash pads. When you pull the fuse out, little bits of fabric and asbestos fabric can get into the air, and that's obviously bad for us. So I wouldn't want to use that. The ceramic fuses as well, they can crack and break. These little dots, these can pop out and there's live connections behind them. It's also a little bit cramped to work in as well. I know we're stripping it out, but no, don't use this. If you've got a fuse board like this, there's a procedure we're going to go through. What you do when you've got an asbestos fuse board, you don't want to start pulling the fuses out. And here's another example. This is a slightly more modern one, like the rewirable fuse box, the Wirex I'm using for these examples. But I'm not particularly happy with this one because there's the plate missing here, the cover is missing, so you've got access to the live terminals. There's also like often little kind of shrouds over these connections, so it's not a comfortable board to work in because we can't isolate this. These tails here are going straight into the supply cutout. There's no isolation, so even though we can switch the rest of the board off and work safely on the circuits, we can't switch this bit off here, and it's not a nice environment to be working around a big lump of live copper like that. So no, you've got to take a view if it's safe to use the old board for your temporary supply. So yeah, sometimes boards can just be too old and no, look at this one here, you don't want to be using that. This is actually still live and in use, but no, you don't want to be using that as your temporary supply, that's done its time. But just because it's old doesn't mean it's bad, and just because it's new doesn't mean it's good. I mean, look at the state of this. This is quite a new thing. You don't want to be using something like that either. So even if it's a newish supply, newish board, you still got to check it's all good and suitable. So there's plenty of old boards where I'm quite happy to continue using it for my temporary supply. I mean, some old boards have got RCDs. These aren't massively old. These got RCDs. This is a Wirex. It's not too bad, is it? I'd be happy to use that, for a temporary supply. It's got its cover on, so you feel a bit safer working there. These are quite neat. But we're electricians, aren't we? So we'll find a few things we don't like about these boards. But yeah, I'll be happy to use these kind of boards for my temporary supply. Yeah, no bother. I mentioned that I like to strip all the cables out of the fuse board, so I know that there's nothing energized within the flat, and it's just the temporary sockets. Every other circuit's gone now, so people can work safely. And we're talking about a 3-bedroom house, but I just want to mention that you could be working in a flat. Now, the downstairs flat, that's still all energized. The upstairs flat, you've ripped everything out of the fuse board, so you think everything's dead. But don't forget, what's your floor is their ceiling, and they're going to have cables in the same void, possibly, which is still live. So even though you think everything's dead in your flat, there's still going to be live conductors from downstairs in the same void as your cables. So you always have to take good care, and it's sometimes difficult to know what cables are doing what. You've got to kind of follow things. You only know if something's dead when you can see both ends of it. If you're putting something out, you've got to know for a fact that it's dead. Don't go cutting through cables thinking it's dead, because this might be energized from downstairs. Here's an example of what I was talking about. So if you're working in a block of flats, there's going to be people above and below you possibly. So what's your floor is their ceiling. And what's going on here? Who knows what's what? This could be downstairs as lighting cables, or it could be your ring final cables. You just don't know. Sometimes it's difficult to tell if it's dead or not because there's nothing to test on. You haven't got a junction box, so you can't get a live and neutral test or a live earth test, you've just got the cable coming through. You can use a volt stick and see if there's any voltage in it, but that's not a reliable method of proving dead. You just have to be very, very careful. I always try and trace out cables so I know what's what. When you're removing cables, you want to find both ends of it really, and you know that you're not interfering with somebody else's electrics. So you've got to take good care when you're stripping out. Don't just think the power's off and start ripping everything out, because you might be ripping out downstairs the electrics as well. They won't be very happy, and it's also potentially dangerous. Right, so that's the end of day one, and what have we achieved? Well, we've confirmed that we've got a good ZE, so we've got unearthed into the property. We're also happy with the supply cutout. We don't need to call a DNO to come and have a look at that. We've contacted the supply company, and they're going to send somebody around to fit an isolator so we can swap this fuse board out. We're going to stick with this fuse board for now because there's lots of dirty work which is going to get done, and we've got no conductors in yet, so we'll stick with this fuse board for now. To run a temporary supply, we put a B20 plug-in MCB in there, run a radial circuit to an RCD socket so we can get some power for the kettle in the battery charges and a bit of light if we need it. We've removed all the conductors from the consumer unit, obviously under safe isolation. We've tested everything was dead. We've worked safely. We've removed all the conductors from the consumer unit, so we're happy that there's no energized circuits throughout the flat, throughout the house. But if we are in a flat, there could be people above and below us, and we know that in those voids there could be live cables from the flats above and below us, so we've got to take very good care when we're stripping out the old electrics for our property. This is all done by skilled electricians, but if you're an apprentice, your boss will be there showing you what to do. So everybody's work safe, and we're all good to start tomorrow. Okay.